Welcome, everybody. Thank you for joining us. Our aim is to both entertain you, more importantly, to give you some education. Tonight's topic is going to be on autism or ASD, autistic spectrum disorders. So let's get right into it.
All righty. So let me start us off, Dr. Gutman. Is there a link between glutathione and autism spectrum disorders? And if so, where can we find it?
Well, this is a great way to start. I remember when I first started lecturing on glutathione, people would come up to me and say, Dr. Gutman, does raising glutathione have anything to do with autism? And my answer would be, I don't know, or no. And many people would tell me, listen, I've got a son, I've got a daughter, I've got a nephew, I've got a neighbor. They've been taking the Immunical product to raise glutathione, and their autistic child has gotten better. Well, I found that interesting, and I kept on hearing those stories. But when asked in a public domain on stage in front of hundreds of people, does glutathione have anything to do with autism? I still would have to say, I don't know or no, because there wasn't any evidence that it did until, well, I'll let you guys go through this exercise yourself. The website pubmed.gov, this is the foremost source of medical articles available in the world. Now, a lot of people on this call today even access this daily. It's an essential tool for the sharing of scientific information. So for those of you who have not heard of this site, it's critical for anyone doing research. But I got to warn you, it's a bit of a rabbit hole that you might end up spending hours, weeks, or months at a time. So when we look at this chart here, I put in a search term with the two terms glutathione and autism. And the graphic here shows the amount of papers written in different years. From 1978 up until the middle of the graph, there really was nothing written on autism. And what's most noticeable here is that there's this sudden spike in 2004. And boom, an avalanche of papers started being published. And why all of a sudden, what happened in 2004 that changed my perspective on autism, that allowed me to answer the question whether glutathione had anything to do with autism? What happened in 2004? Well, this groundbreaking study was published. It came from a team led by Dr. Jill James. Many of you are aware of if you work in autism, working out of Arkansas, of all places. This was exceptional news to everyone in the autism research community. And the paper was called Metabolic Biomarkers of Increased Oxidative Stress and Impaired Methylation Capacity in Children with Autism. Now, that's a bit of a mouthful, but let me just explain what they did. They collected blood samples of both children with autism and children without autism and compared them for a whole bunch of different biochemical markers or blood tests that related to a metabolic process called methylation. Now, again, I know some of you are familiar with these terms, but I want to be sure to keep parents and non-scientists on the loop here. And of course, oxidative stress is a reflection of the balance between antioxidants and free radicals. So they did these blood tests to look at methylation and oxidation. So here you see a table. I'm sorry, it's impossible to read here because the numbers are so small. But if you want to get into more detail, remember pubmed.gov and enter the name of the study in the search window. But let me give you the quick bottom line here. Hear this up. Just about 80% of the kids with autism had abnormalities in glutathione functioning. This is relevant information. 80% of these kids had abnormal glutathione.
Wow, that is very significant. So if glutathione is so important, let's take a look at that. What is glutathione?
Well, many of you already know this material, but again, there's going to be new callers on all of these programs. We could spend hours talking about this. And of course, I've written many books on the topic. But for those of you who are new, glutathione is a little molecule that occurs naturally in all of our cells. And the understanding of its many roles is expanding every year. And getting back to PubMed, this slide is actually, I think, outdated by now. There's over 175,000 articles if you just enter glutathione in the search tool. Just to put this in context, what does 175,000 articles mean? If you entered vitamin C, you get back 70,000. Vitamin E gives you 45,000. So glutathione will get you more scientific medical articles than vitamin C and E put together. So anybody who's not heard of glutathione before, it will become part of our regular language in due time. So what does glutathione do for us? Well, dozens of things, but if we can summarize the four most important, you'll understand 90% of its role. Remember the word idea. Glutathione, what a great idea. I stands for the immune system. D stands for detoxifying. E stands for energy, and A stands for antioxidant. If we look at these in turn, glutathione can be perceived literally as food or fuel for your immune system. People who are low on glutathione have a weak immune system. People who have normal glutathione levels have a more optimized immune system. D for detoxification. Well, there are thousands and thousands of toxins in the food that we eat, the air that we breathe, and the water that we drink. We would succumb to our environment in days were it not for the detoxification that takes place by glutathione. And the highest levels of glutathione to be found in the body is in the liver, which is, after all, your main organ of detoxification. We could talk about E, energy. Our cells derive energy from these little structures called mitochondria. And these mitochondria would literally burn up from free radical damage were it not for a constant supply of glutathione. And antioxidant, this is the role that most people recognize for glutathione, and glutathione is referred to as the master antioxidant. And that's because all of the antioxidants we know of cannot function without the presence of glutathione. So glutathione, the master antioxidant.
So Dr. Gutman, for the listeners who are interested in the biochemistry here, could you take a bit of a closer look for us?
Yeah, for sure. But we won't get too deep into it, but we'll dig in a little bit deeper. And the slides that I'm going to show, we will post a copy of this program in a couple of weeks so you can study the slides at your own pace. Here's one. Originally, I was going to get into several metabolic pathways where glutathione has direct relevance to SD, but I'm going to make it as brief as possible. Let me just flash these overview slides onto your screen. So if you want, you can access these and look at them at your own pace when the webinar is posted later on. You'll see one pathway here circled in red where folate and B12 abnormalities relate to something called the MTHFR gene. MTHFR. Some of you have heard of that before, and it relates to a number of neurological disorders, including autism. And very often we find a problem in that pathway with the MTHF pathway. Here's the methylation pathway. Again, without getting into details, occasionally people with autism and other neurologic diseases end up with an abnormality in that pathway. And here is the common endpoint the transsulfuration pathway. And what that is the pathway in which glutathione production is made. That's where glutathione is made. So if you want me to walk through all of this in more detail, you can access an older lecture I've online on YouTube. You could find it there at that address there. Make sure you've got a nice stiff cup of coffee because it's about an hour long. But it'll go through those pathways for the keeners out there. So these are tough slides for most of us, but just to refine this down to simpler terms. One, glutathione is intimately related to methylation pathways. Glutathione is equally intimately related to MTHFR gene dysfunction. And I may suggest that the parents, if you're a parent or a relative of a kid with autism, you may want to invest in an inexpensive genetic testing that can determine MTHFR gene abnormalities. It blows my mind that these are available online for about $100. It's we see these sites where you just spit into a bottle and they do genes for you and tell you ancestry.com, places like that. To me, for a 67-year-old doctor, this is still science fiction. But you can get the MTHFR gene examined and be able to almost predict whether there's going to be a problem. And number three, the blockages, glutathione production. Remember that last section there where glutathione is made. All of this stuff before it can be bypassed by providing bioavailable cysteine, which is the major precursor for glutathione. In other words, the problem may be in glutathione insufficiency, and we might be able to get around this issue by jumping into the pathway at a later point with a dietary intervention. Yes, a dietary intervention. In other words, at the most basic level, glutathione augmentation or raising glutathione appears to be an absolutely critical key intervention.
So, Dr. Gutman, this begs the question, how do you raise glutathione?
Well, that's certainly a key question. Number one, you can't raise your glutathione levels by eating glutathione. When you eat glutathione, it becomes rapidly broken down in your digestive tract, and you just end up wasting your time and your money. Glutathione needs to be made inside of your cells. So eating glutathione isn't going to make your cell manufacture glutathione. What you need to do is give your cells the building blocks, the specific nutrients your cells need to make glutathione, what we call precursors. So it's the use of precursors, such as Immunical, that allows the cell to make glutathione. And here you see two books that every pharmacist and every doctor in Canada and USA use. The American one is called a PDR, or the Physician's Desk Reference. And the Canadian one is the CPS, the Compendium of Pharmaceutical Specialties. And in there, if you're looking for a way to raise glutathione, you don't find glutathione because it doesn't work. You find two precursors, the drug NAC, N-acetylcysteine, which is a fantastic way to raise glutathione, but it does have significant side effects, and Immunical, a natural product that doesn't have the same spectrum of side effects and has the advantage of having a source of rich nutrition.
Dr. Gutman, can you share some studies that have been done with Immunical?
I actually, when I read the 2004 article that said that 80% of autistic kids were glutathione deficient, I got to work right away on putting together a study. Now you'll see that this study was published in 2008. In research, that's right away, 4 years. And so did this cautiously. It hadn't been done using a protein precursor before. So you see the study, oral tolerability on a cysteine-rich whey protein, Immunical, in autism. And we had to make sure in any early study, you can't just launch into a major double-blind study. You have to make sure that it's tolerable, that it's safe, that there is no downside. And so not only was it important to establish the concept was sound and had the potential to be further investigated in larger studies, but there were challenges from the autism community about whether it was in fact safe. Let me explain. As many of you know, selected dietary restrictions seem to show benefits in these kids, and certain foods have been shown to be potentially problematic. One type of food that was often eliminated was dairy or dairy products. And in my experience, many problems besides the obvious lactose intolerance surrounding dairy products lies in the casein content. Dairy products are very complex. They have many different types of peptides and many different types of proteins and other contents. But usually the issue is found in the casein. Casein is just one of the many subproteins that you could find in milk, and it represents the most common allergy, but it does not show up in Immunical. And so, yes, we proved that it was in fact safe, it was tolerable. And in the small numbers that we used, we didn't reach statistical significance because we were small numbers, but these kids got better. So this was picked up by a fantastic group from Nova Southwestern University in Florida. They took it to task. They were impressed with the results, and they wanted to do a large study themselves. Now, human studies in autistic spectrum disorder are especially difficult. There's still no fully diagnostic biochemical endpoints because of autism is variable. And the kids obviously require a different level of consent and on and on. It took us 10 years. It took us 10 years to complete this study because of the difficulties dealing with A, pediatrics, and B, autistic kids.
Regarding new evidence, Dr. Gutman, could I ask you to tell us about this new and seminal paper recently published in Frontiers in Psychiatry?
Well, here it is. Here's that paper after 10 years of study. It was led by Dr. Anna Castajon and included members of what's called the Mailman-Siegel Center. This is a major autism research organization. Just a ton of work published in 21 and an exceptional paper that you need to get your hands on. You'll see in the title that this human study was randomized and double-blinded, placebo-controlled, and all the other features of what's called a gold standard study. This is the highest level of research that you can do. The intervention that was used was the glutathione precursor Immunical, best described as a cysteine-rich whey protein isolate. So you see that all in the title. And this very busy slide looks at the behavioral parameters that were measured. I'll get into that in a moment, but again, I urge the researchers and clinicians that are listening to this to access that paper on PubMed, and they'll see the number here. You can find it very easily. A simpler graph shows here glutathione levels. So clearly glutathione levels were greatly improved. That's a green box, and as opposed to the red bar, which was the placebo. So we knew this was going to happen. We have so many studies showing that Immunical raises glutathione, but of course it's important to demonstrate that in autistic kids. So we've answered one of the major deficiencies shown in that original 2004 paper. And finally, the question that's much more important to the clinician, to the parent, to the child, are these kids actually feeling and doing better? How has this affected their quality of living? Sometimes the pure scientists get too focused on lab results. But the answer to those questions is yes. When we look back at the measurements pertaining to skills of daily living, socialization, reduction in maladaptive behaviors, these get better across the board. And what's also important to note is that despite the efforts to randomize these kids into treatment and placebo groups, a close analysis of their behavior at the start of the study showed that the placebo group, before anybody got any placebo or Immunical, they scored slightly better just out of chance. In other words, if the treatment group showed better scoring at the end of the treatment, that would imply that the intervention was even better than the numbers show. Now, here's where it gets a bit more complicated. There seemed to be a subset of autistic spectrum disorder kids that did much better than the overall population of autistic kids examined. This is important to tease out because since this is the first major study of its kind, it gives us information that perhaps there is a targeted group of autistic patients that may benefit more from this strategy. Remember, ASD, autism spectrum disorder, is a very mixed phenomenon. So, lack of a better term, we separated the groups into responders and non-responders, even though the non-responders responded, but not as well as the responders. So let's look at the two tables. Overall, these kids improved in the areas in the blue labeled box, very promising. But look at the responders in the green lettered box. Look at the amount of statistically relevant improvements in behavioral parameters that resulted. Improvement in adaptive behaviors, communication skills, and even gross motor skills. This needs to be looked at even closer. So the responders, they were generally older kids, and the responders started off with higher baseline glutathione levels. How do you interpret that? Well, two things. Because the kids were older, remember, the kids we were looking were between ages 3 and 5, and clearly a 5-year-old is dramatically different than a 3-year-old. And let's just move on. Because the responders were older, it may be that the intervention with the Immunical works better in older kids. Okay, so we need to look at that still, but this is our suspicion. The study would likely be even stronger if a larger age group, let's say 3 to 8-year-old children, would be looked at. And because the responders started off with higher baseline glutathione levels, number one, maybe there's a threshold where glutathione levels need to be so that these kids are functioning better, and that the threshold was easier to reach with the dose that was supplied. And number two, which in my personal opinion has a strong likelihood, more kids would have shown a positive result if the dose was increased. And given that the intervention was so well tolerated and it's been on the market for over 25 years, this, I think, is a reasonable suggestion. So maybe we need to use a slightly higher dose in autistic kids to get even better results.
So if we want to find out more about glutathione, where can we go?
Well, you can always go to PubMed and look up these articles, but for many that will be challenging. It is a very dry read. Something that's a little bit more accessible, of course, is my book on glutathione, and not hard to find. One place that you can find it is on Amazon or Amazon Kindle, where you can find individual chapters. Some of these individual chapters, I believe there's one on autism as well. I believe for certain members of Amazon Prime, they're free.